Just 1 hour class. Okay, sorry. So about the esophageal groove, I explained about the main purpose of the esophageal groove last class. Can anyone say what is the main purpose of it? Okay, can you hear my voice, all of you? Can you hear my voice?
Yes,
Okay, thank you. Okay, can any one of you say what is the main function of the esophageal groove?
to direct the milk to the animals.
Okay, very good. So why the milk has to be directed to the abomasum? Thank you, dear Savior. Your answer is correct. Why it has to be directly sent to the abomasum? Okay, Shagari Khati, your answer is also correct. Okay, fine. We can again start. First, just wait. Somebody answered. I think I'll check. Prevent the milk from fermentation by ruminant microorganisms. Vishmi Malsha, correct. Okay, Himaru Satsara also correct. Tanya, okay, your answer is perfect. Thank you so much. Okay, it's about esophageal groove. Right, okay. So it's a muscular structure at the lower end of the esophagus. So at the lower end of the esophagus, you know, esophagus is an organ to conduct the food. Okay, trachea. Don't confuse with esophagus and trachea. Trachea is for conducting the air to the lungs. Esophagus is for conducting the food to the stomach. Okay, it's a muscular structure. And the esophageal groove is a muscular structure at the lower end of the esophagus. Here in this title slide, you can see the esophageal groove. Okay, the dotted line is esophageal groove. It's a continuation of esophagus. Okay, this esophagus groove is a tube that allow the milk to go directly to the abomasum. Okay, again, look at this picture. Okay, here you all know the compound stomach have 4 main parts: rumen, reticulum, omasum, and abomasum. Okay, in this picture, which one is larger? Which part? Rumen, reticulum? Oh, okay, very good. Abomasum is larger. So, in the calves, abomasum is the largest organ. But when it is developing as a cow, then the rumen will be the largest portion. Okay, you can study this when we are studying about the digestive system detailing. Okay, here the main purpose is to direct the milk to the abomasum. Okay, it is bypassing the rumen, reticulum, omasum through to the abomasum. Bypassing means here crossing. Okay, here the milk is not going into these stomach components. Okay, it is bypassing these 3 components and straightly going to the abomasum. Okay, when the calf is born with esophageal groove. Okay, but when the calf is developing or aging, the function of this groove will decline. Okay, initially the esophageal groove will have a good function. The suckling reflex. Okay, suckling means what? Getting the milk from the teat of the mother through the sucking action. So the suckling reflex and the milk protein stimulate this esophageal groove to open. So in the last class I explained immediately after milk feeding, we should not give the water to the calf because so when during the milk feeding time the esophageal groove will be open. So when we are immediately giving the water to the cow, sometimes through the esophageal groove the water may go into the abomasum. If water go into the abomasum, so the milk which is already there will be a clot, will be formed in a clot-like appearance. Will be so this water may disturb the clot or weakens the clot and that will prevent the digestion of the milk. Okay. So immediately after milk feeding, we should not feed the calves with water because sometimes the esophageal groove may open, the water may go inside the abomasum and that may weaken the clots. So the activity of esophageal groove decreases after weaning. Weaning means after 8 weeks, we will separate the calf from the mother and then we will provide the roughages and concentrates little by little to the calves. So after weaning, the activity of esophageal groove will decrease. Okay. So after weaning and when during the aging, when the animal is getting age or when the animal is growing, the esophageal groove activity will decrease. But we can trigger the activity of esophageal groove under certain circumstances. That is also possible. So I'm not sure this picture will be clear for you, but anyway you can see, I think, anyhow. So you can see what is esophageal groove and you can see the size of these organs. The abomasum is the largest part here because it's a calf, and you can see the location of rumen, reticulum and omasum, and this dotted lines are the esophageal groove. Function is to direct the milk into the abomasum. Here, esophageal groove prevent the milk, especially cholesterol, okay, on the first milk, and that will be highly nutrient of protein, high content of fat. So this is very important for developing immunity in the cow. So to prevent the cholesterol from fermentation by ruminal microorganisms, the esophageal groove is straightly directing the milk to the abomasum. Okay, we all know in the rumen there is no microorganisms, ruminal microorganisms. That's why the ruminants could be able to digest the roughages. So the rumen having the microorganisms, sometimes that microorganisms can ferment the milk. To prevent this, the esophageal groove is directing the milk to the abomasum. Okay, this is the answer for the second question. Okay, I think 3 of you have answered correctly. Okay, reflex contraction is for your reference. Okay, after you providing this assignment, I will explain you about the reflex contraction. Okay, now we can look about factors that affect the efficient closure of the esophageal groove. Okay, as I already said, when the calf is just born or when it is in about 2 weeks or 3 weeks, the activity of the esophageal groove is high. But when the calf is getting age, the activity of the esophageal groove will decline. So there are some factors that will affect the activity of efficient closure of esophageal grooves, that are age of animals. Okay, when the animal is getting age, the activity of esophageal groove will decrease. It is also depending on the method of drinking. Okay. So there are some drinking methods, that means using nipple pails and using buckets. Okay, when we are using the buckets, the activity of esophageal groove will decrease. Then the composition of the liquid consumes, and also because the proteins and all those things also influencing the closure of esophageal groove, and the site of delivery to the esophagus also affect the esophageal grooves. So there are four factors, main factors that can effectively that is influencing the closure of esophageal groove: age of animal, method of drinking, the composition of the liquids or the nutrient component of the liquid which is consumed, the site of delivery, so in which portions the milk is delivered into the esophagus. Okay, inside the esophagus, in which part the milk is delivered. That is also can affect the closure of esophagus. Okay, now we can study the calf's digestive system. Excuse me for a while. Okay, we can study about the calf's digestive system. So about the calf digestive system, we can largest part is, so what is the largest part in the calf's digestive system? Anyone? So among the stomachs, there are four main stomachs. It's complex stomach. So which is the largest part? Okay.
Abomasum.
Okay, very good. Abomasum. So what is the largest part in the well-developed cattle?
Rumen.
Okay, very good. So now we are going to study about the abomasum. For the first 2 weeks of the calf's life, it is a monogastric or simple stomach animal. Okay, because it is not having any rumination functions. Okay, it is just functions like a monogastric animal. Okay, the monogastric animal will normally have simple stomach structures. Okay, there is no any complex stomach structure in monogastrics. Okay, there's no any rumination activity on monogastrics. Just like this, for the first 2 weeks of the calf's life, the stomach is just like monogastric animals. Okay, it is only going to use the abomasum to digest the milk, or there may be some milk replacers. Okay, it can be the milk direct from the mother, or it can be through the artificial milk feeding like skim milk, or by any ways, it is going to only use the abomasum. So here abomasum is releasing digestive enzymes to break down the fat, carbohydrates and proteins in the milk. So here for the first 2 weeks of calf life, the calf will just function like a monogastric animal. The reason is there is no any rumination. It is only going to use the abomasum. Here the abomasum also can be called as true stomach. Okay, true stomach, because it can release some digestive enzymes and it can break down the fats, carbohydrates as well as proteins. So the energy requirements are made for the absorption of glucose from the abomasum. So here the abomasum is breaking down all the nutrient particles is 3 to 4 months old. The abomasum makes up 20%. So earlier, for a newborn calf, the abomasum takes up about 60% of human body capacity of the calves. But when it is about 3 to 4 months old, it will make just 20% of the capacity. So when the animal matures, that shrinks only to 8% of the stomach. So When the animal mature, it will be about just 8%. Okay. Please look at the three pictures that is on the corner of this slide. What is happening on the first week of life? Just look at the portions, the stomach components in the portion. Abomasum is 60%, rumen 25, omasum 10 and reticulum just 5. This is on the first week of life. So on the second week of life, on the 12th week of life, abomasum is just 20%. 12th week means how many months? So 12 week means how many months? 1 month. Okay, 3 months. So on about 3 months, the abomasum is just 20%, but the rumen is 65%. Okay, the obesum is still 10%, reticulum is also 5%. But just look, for a matured cattle, rumen is 80%. Okay, for a well-developed cattle, rumen is 80%, abomasum is just 8%. Omasum 7 and reticulum is not changing all over, that is just 5%. So just look at the proportions of rumen and as well as abomasum. When it is calf, the abomasum is occupying about 60%. But for a matured cattle, it is just 8%. Okay. Please remember this percentage values. You may be asked these values on your quiz examination. And the rumen, so you can simply see the rumen development with these pictures. So initially on the first week of life, it is just 25%, but at the maturity, it is 80% because the rumen is the main part or main component in the ruminants. So the rumen is made up of two main layers, epithelial layer. So epithelium is just covering. So you have already studied that in the tissues, there are various kinds of epithelium. So how can we divide the epithelium into mainly two portions? We can divide the epithelium into two types. Anyone? Very good, Avarjana. Simple and complex epitheliums. Okay, and it is having muscular layers. Okay, the rumen is made up of two main layers, epithelial layers and muscular layers. The muscular layer is responsible for the contraction of the rumen and gives support to the epithelial layers. The main function of the muscular layer is contraction and supporting the epithelial layers. So prior to weaning means what? Separation of the young one from the mother. Prior to weaning activity, the rumen must develop to be able to absorb metabolizable volatile fatty acids. Okay, you will study these volatile fatty acids under carbohydrate digestion. Okay, just remember this point. You can check later. So prior to the weaning, the rumen must be able to absorb this VFA, volatile fatty acids. So VFA are the last components in the carbohydrate breakdowns. Okay, we can study it in later coming sections. Calves that do not eat trifeeds, trifeed means the concentrate roughages, will not develop a functional rumen. Okay, for the development of the rumen, we have to provide the concentrates as well as the roughages. Okay, after 10th day, we have to just spread the concentrate over the muscle of the calf. So at the time, the calf will lick the concentrate. Okay, we have to apply the concentrates over the muscle portion as well as slightly over the nose. Muscle portion over the of the calf, not inside the nose. Okay, just on the muscle portion, and we have to allow the calf to lick the concentrates. So the consumption of the concentrates will increase the rumen development. Okay, it can be started after the 10th day of the in the calf's development. It is the grain that develop the rumen and allow the calf to transition from milk-based to corn-based diet. Okay, so we can use some grains or concentrates to develop the rumen. Okay, development of rumen is very important to change the animal from milk-based feed to concentrates or roughages-based diet. So I'm again explaining the slide. At the time of weaning, the rumen must be able to absorb some volatile fatty acids. So for development of the functional rumen, we have to give concentrates as well as roughages for the cattle, for the calves from the 10th day onwards. In a newborn calf, the rumen makes up 25% of the calf's stomach capacity. Okay, just we already studied. For the newborn, it is will about just 25%. The abomasum will be about 60%. So as the calf ages, the rumen grows and develop. These folds become less prominent and the esophageal groove will disappear. So when the calf get aging, the rumen will develop and the esophageal groove will not have any function and it will gradually disappear. So in this picture you can see the development of the rumen. So and this is about the proportion of the stomach parts. So this picture is about the development of bovine stomach compartments from birth to maturity. Okay. And when saying about the milk digestion, when the calf drinking milk or milk replacers, it will straightly go to abomasum. Within 10 minutes, the milk form clot in the abomasum. Okay, it is very important. Okay, within 10 minutes, the milk form clot means the somewhat solid, semi-solid structures. Okay, the milk will be in liquid state. It will be transformed into clot in the abomasum. Clot means just like semi-solid substances. So from the coagulation of the milk protein or casein, the enzymes renin and pepsin and hydrochloric acid. Sorry, one second. Okay. So in the abomasums, the milk will undergo coagulation and it will form the clot-like structures. So there are some other components than the proteins that are whey protein, lactose, and minerals that will be separated from the curd. Curd means the clot-like structure, and they will pass into the small intestine. So the other milk components other than the proteins, such as whey protein, lactose, and most minerals, they will be separate from the curd. Curd means immediately after the milk getting into the abomasum, it will be transformed into clot-like structures because of the coagulation. So the proteins will coagulate and other structures will rapidly pass into the small intestine. Okay, the lactose, that is the main portion which is generating energy, that is digested quickly. In contrast to the casein and fat, provide immediate energy to the calf. Okay, the casein and the fat. Casein is the main protein in the milk. The casein and the fat will digest slowly than the lactose. Lactose will immediately digest and that will provide immediate energy to the calf. The clot is then slowly absorbed by the bloodstream over the next 12 to 18 hours. Okay. First, when the calf drinks milk, it will form the clot. The proteins will coagulate, and the other components will pass into the rumen, and the lactose digests quickly, and it will provide energy, and the nutrients in the clots will slowly absorbed over the next 12 hours. And this is the end about the esophageal groove. Okay, with that we can end up the today's class, and from the next class we can continue. Thank you.